You've probably heard of cigarettes, the fallen muse of modern consumer culture. With their slender form, fleeting sense of relaxation, and that white smoke that has captivated more than 1.3 billion people across the planet. But have you ever wondered, how does this industry manage to produce millions of tons of tobacco every year? The journey of those familiar cigarettes begins with a plant you may have never seen up close: tobacco. In sun-drenched fields, delicate leaves are harvested with remarkable care and near-perfect precision, then transported to factories where modern technology blends with time-honored recipes to craft sleek cigarettes or high-end cigars. Today, join Agriculture Insight as we uncover the inner workings of the multi-billion-dollar white smoke industry and explore why it remains tied to billions of lives despite constant controversy over its impact on health. Before modern cigarettes came into existence, humans had been using tobacco leaves for thousands of years. In ancient Mayan culture, tobacco was considered a sacred gift to the gods. By the 16th century, it had followed European explorers to the New World, then spread across the globe, becoming intertwined with colonialism, war, and the glamour of Hollywood. You may have never seen a tobacco plant with your own eyes, but every year, the world still harvests over 6 million tons of tobacco leaves, fueling an industry worth nearly $900 billion. China currently leads in production with more than 2.6 million tons annually, but the most famous tobacco brand in the world comes from the United States, Marlboro, which accounts for up to 14% of global consumption. And you, what's your number one brand? And every great story has a beginning. For this smoky muse, it all starts in the sun-drenched tobacco fields, where warm summer breezes signal the first whispers of harvest. From around July to September each year, the tobacco fields enter harvest season. Harvesting requires great precision, relying on both experience and traditional principles. Specialized machines move slowly through the head-high rows of plants. Beneath them, a system of sharp rotating blades precisely cuts the mature leaves close to the ground. Immediately afterward, soft conveyors receive and lift the leaves, preserving their shape and moisture while minimizing tearing or bruising. Leaves must be picked when they are not too wet to prevent bruising, yet not too dry, which makes them brittle. The ideal temperature is between 20 to 25 degrees Celsius, and harvesting typically takes place between 5 and 9 a.m., when the leaves are still supple and retain a healthy sheen. The leaves are delivered directly into a large ventilated container at the rear, designed to prevent moisture buildup and premature fermentation. Once full, an automatic unloading system transfers the leaves to a detachable bin or a specialized truck moving alongside. On average, a single machine can harvest about 5 tons of fresh leaves per day, 8 to 10 times more efficient than manual labor, while also reducing risks and improving efficiency across the entire production chain. At some cigar tobacco farms, machines are used to harvest the entire plant. These devices cut the stalk at the base, gently lift the full row, and automatically hang the plants onto integrated curing racks, ready for drying. Notably, keeping the stalk intact allows sap to continue distributing into the leaves during drying, making them softer, more elastic, and rich in natural oils, crucial qualities for producing smooth, flexible, and glossy wrappers for premium cigars. In Cuba, Nicaragua, and the Dominican Republic, the birthplaces of hand-rolled cigars, the tradition of harvesting by hand is still carefully preserved, serving as a tribute to the leaves that will become the soul of premium cigars. Unlike the mechanical precision of machines, manual harvesting follows a slow, deliberate rhythm rich with craftsmanship. Skilled workers closely examine each leaf, using its color, sheen, and elasticity to judge the perfect stage of ripeness. After harvesting, the leaves are bundled into small groups and placed in woven baskets or breathable racks to maintain their shape. Though labor-intensive and slower, this meticulous process is what gives handmade cigars their unique value. why a single premium cigar can fetch hundreds of dollars, while a pack of machine-made cigarettes costs just a few. From here, the leaves begin to diverge, some destined to become artisanal cigars, others entering the industrial pipeline of mass-market tobacco. Let's begin with the remarkable story behind every cigar. Not just something to smoke, but a product born from time, technique, and traditional craftsmanship. Immediately after being harvested, tobacco leaves enter the curing stage, the first and one of the most critical steps in cigar production. The leaves are hung in curing barns or sheds, where temperature, humidity, and airflow are tightly controlled. Depending on the leaf variety and desired flavor profile, different methods may be used. Sun curing, air curing, smoke curing, or heat curing. This process usually takes several weeks and requires great precision, as even small deviations can significantly impact leaf quality and the final cigar flavor. After curing, the properly dried tobacco leaves move on to fermentation, an essential stage for refining flavor and stabilizing leaf structure. The leaves are stacked into large piles called pilones, where heat naturally builds up through biological decomposition. During this phase, unwanted compounds such as excess nicotine and ammonia are removed, while natural aromas are enhanced. Workers regularly turn the piles to control temperature and humidity, and lightly moisten the leaves to maintain optimal conditions. Once fermentation is complete, the tobacco leaves are carefully sorted based on size, color, softness, and flexibility. Each cigar requires 3 types of leaves: the wrapper, outer layer, the binder, middle layer, and the filler, inner core. The wrapper is the outermost leaf, directly impacting the cigar's appearance and flavor. The binder holds the filler together, providing structure, while the filler, the heart of the cigar, is made up of several smaller leaves blended according to a specific recipe. This filler blend is what gives each cigar its unique flavor profile and signature character. For premium cigars like those from Cuba or the Dominican Republic, hand rolling remains the gold standard. Skilled artisans carefully select the appropriate filler leaves, arrange them according to a specific blend, then roll them tightly with a binder and finish with a smooth wrapper. Each cigar is shaped, the head is twisted, then it's placed into a mold for pressing and undergoes thorough inspection before storage and packaging. While each artisan can roll only a few dozen to a few hundred cigars per day, their precision and craftsmanship result in a level of quality that's unmistakably superior. Although the cigars are already complete in appearance, they still require time to rest. This post-roll aging stage lasts from 2 weeks to 3 months, allowing the tobacco leaves to blend and the flavors to stabilize. During this period, the compounds in the filler, binder, and wrapper gradually harmonize, creating a balanced aroma, taste, and burn. As a result, the cigars reach their ideal state before being packaged and shipped. Meanwhile, in large-scale factories, automated cigar rolling machines are used to boost productivity and standardize the product. First, tobacco leaves are fed into the machine and cut to pre-programmed specifications. Once the filler, binder, and wrapper layers are precisely arranged, a system of rollers tightly wraps them into the shape of a finished cigar. The head of the cigar is then neatly twisted by the machine to ensure uniform size and appearance. Next, the cigars pass through a preliminary inspection line before moving on to the next stage. Specialized equipment is used to assess the roundness, firmness, and tightness of the cigar's head, as well as the condition of the wrapper surface. Any cigar showing defects, such as loose rolling, torn wrappers, or incorrect dimensions, will be rejected or redirected to a separate category for further handling. After that, each cigar is carefully wrapped in a thin layer of nylon to protect its outer structure, maintain optimal humidity, and ensure complete hygiene. This wrapping also helps shield the cigar from environmental factors during transportation and storage, preparing it for the final packaging stage. And now, let's explore the cigarette manufacturing factories, where each cigarette is produced through a closed-loop process that is both rapid and highly precise. Unlike the artisanal craftsmanship of hand-rolled cigars, cigarette production is highly industrialized, driven by extensive automation and advanced technology. Unlike cigars, which require each leaf to be hung individually, tobacco leaves used for cigarettes are typically stacked in large cages or mesh containers, then placed into sealed curing chambers with automated temperature and humidity controls. These high-capacity systems operate continuously and can cure several tons of leaves each day. The drying process removes moisture and stabilizes the leaf structure, preparing them for further processing. Once the leaves reach the desired moisture level, they are compressed into tightly packed bales for easy storage and transport to the main processing plant. At the factory, the tightly packed bales of tobacco leaves are unpacked and fed into a modern cutting system. Here, the leaves are shredded into fine, uniformly sized strands, making them easier to roll into paper and ensuring a consistent, even burn in every cigarette. These shredded tobacco strands are then moved into a blending process that follows a proprietary formula unique to each brand. In addition to the primary tobacco material, the blend may include several additives such as flavor enhancers, humectants, and aromatic agents, designed to smooth the draw, adjust the scent, and enhance the overall smoking experience. The entire process is strictly monitored and controlled to ensure uniformity and maintain the final product's quality standards. Once the tobacco filler is ready, the automated production line feeds it into specialized rolling paper tubes, ensuring an even burn and controlled smoke output. The processes of rolling, cutting, attaching the filter, and shaping the cigarette are all fully automated, producing thousands of cigarettes per minute with high precision. Once the finished cigarettes meet quality standards, they are transferred to a fully automated packaging line, a highly precise and tightly controlled process. Every 20 cigarettes are neatly aligned and inserted into a specially designed cardboard box. These boxes are built to withstand transportation while also clearly displaying the brand's colors and imagery. Next, each pack is wrapped in a layer of foil or thin aluminum film to preserve the aroma, block moisture, and shield the contents from environmental factors. This is followed by an outer shrink-wrap plastic layer, which enhances durability and gives the final product a sleek, polished look by the time it reaches the consumer. Thanks to advanced automation, modern factories can produce hundreds of thousands to millions of cigarette packs per day with near-perfect consistency. And that is the meticulous journey, from delicate leaves swaying under the sun and wind to the iconic product of a multi-billion-dollar industry. Are you curious about how farmers cultivate the vast tobacco fields behind the billions of cigarette packs produced each year? That journey begins with tiny seeds carefully germinated in soil trays or greenhouses, where light, temperature, and humidity are strictly controlled. After about 4 to 6 weeks, once the seedlings reach a height of 15 to 20 centimeters, they are transplanted into the fields. Today, instead of planting each seedling by hand, many modern farms use specialized tobacco transplanters. These machines can automatically drill holes, place the seedlings, cover them with soil, and gently press the surface, all in a single pass. Thanks to this technology, thousands of tobacco plants can be planted in neat, uniform rows within just a few hours, saving labor while ensuring optimal spacing between plants. Tobacco thrives in loose, well-drained, nutrient-rich soil. Throughout its growth cycle, chemical fertilizers, pesticides, and herbicides are frequently applied to prevent pests and diseases and to ensure the leaves meet commercial quality standards. However, the heavy reliance on these chemicals silently contributes to soil and water pollution, posing a serious threat to the surrounding ecosystem, an often overlooked dark side of cultivating one of the world's most profitable industrial crops. Now, each time you hold a cigarette in your hand, the smoke you exhale carries more than a habit. It embodies the essence of the earth, the sky, and the hands that shaped it.
Every great whiskey starts with a solid foundation. The grains. The choice of grains isn't just a matter of convenience, it defines the very character of the whiskey. Bourbon, the quintessential American whiskey, must contain at least 51% corn by law. The corn gives bourbon its signature sweetness and smoothness. Rye whiskey, by contrast, requires at least 51% rye, resulting in a spicier, more robust flavor. Scotch whiskey, on the other hand, primarily relies on malted barley, which creates rich, malty, and sometimes smoky notes. Once the grains are selected, they must be carefully prepared. The grains are cleaned to remove any dirt or impurities. High-quality grains are essential. Any flaws or inconsistencies at this stage could affect the final taste of the whiskey. The cleaned grains are then stored in silos, waiting for their turn to shine. With the grains ready, the next step is to break them down, literally. The grains are sent to powerful industrial mills that crush them into a coarse flour-like substance known as grist. The goal of milling is to increase the surface area of the grains, which allows for more efficient extraction of starches and enzymes during the next stage. If the grind is too coarse, the starches won't convert effectively. If it's too fine, the mash will become gummy and difficult to work with. Striking the right balance is crucial. Different distilleries have different milling techniques, often tied to the type of whiskey they're producing. For example, Scotch whiskey producers tend to use a coarser grind to enhance the malty character of the whiskey, while bourbon makers prefer a finer grind to maximize the sweetness from the corn. The freshly milled grist is then transferred to the mash tun, where the next magical phase begins. Mashing is where the real transformation begins. The milled grains are mixed with hot water in a large vessel called a mash tun. The temperature is carefully controlled, usually between 60 to 70 degrees Celsius. This activates natural enzymes in the grains, which break down the complex starches into simpler sugars like maltose. This process, known as saccharification, creates a thick, sugary liquid called wort. The mash tun is essentially a giant brewing pot, and the process resembles making beer. The choice of water is critical here. Soft water tends to produce a smoother whiskey, while hard water, rich in minerals, can create a more robust flavor. Many distilleries guard the source of their water as a closely kept secret, claiming it's one of the keys to their whiskey's unique taste. The mashing process typically lasts several hours, during which the mash is stirred continuously to ensure even conversion of starch to sugar. Once the wort is fully converted, it's separated from the solid grain husks through a process called lautering. The sweet wort is drawn off, leaving behind the spent grains, which are often recycled as livestock feed or fertilizer. The wort is now ready for fermentation, the step where the alcohol magic begins. The wort is cooled down to around 20 to 30 degrees Celsius and transferred into large fermentation tanks, often made of wood or stainless steel. Yeast is then added to the wort. Over the next 48 to 72 hours, the yeast goes to work, consuming the sugars in the wort and converting them into alcohol and carbon dioxide. This process also creates a variety of complex flavor compounds, including esters and phenols, which contribute fruity, floral, and spicy notes to the final whiskey. Shorter fermentation periods tend to create lighter, cleaner flavors, while longer fermentations develop deeper, more complex notes. The wash is transferred to copper stills, either pot stills or column stills, where it's heated. Since alcohol has a lower boiling point than water, it begins to evaporate first. The alcohol vapors rise through the neck of the still and are then condensed back into liquid form. Pot stills are used for single malt Scotch and Irish whiskey. They produce a richer, more flavorful spirit, but the process is time-consuming and requires more labor. Column stills, on the other hand, are used for bourbon and American whiskey. They allow for continuous distillation, which produces a lighter, more consistent spirit. Distillation typically occurs twice for Scotch and 3 times for Irish whiskey. The goal is to separate the heads, first distillate, and tails, last from the heart, middle cut, which contains the purest alcohol and flavor compounds. The heart is collected, while the heads and tails are recycled or discarded. The distilled spirit is now technically whiskey, but it lacks the rich color and deep flavor we associate with aged whiskey. That's where the oak barrels come in. Bourbon must be aged in new American oak barrels that are charred on the inside. The charring process involves burning the inside of the barrel with an open flame. This caramelizes the natural sugars in the wood, creating flavors of vanilla, toffee, and spice. Scotch and Irish whiskey can be aged in reused barrels, often former bourbon or sherry casks, which add layers of complexity. As the whiskey ages, it expands and contracts within the barrel due to seasonal temperature changes. This allows the whiskey to interact with the wood, absorbing tannins and other flavor compounds. The aging process can last anywhere from 2 years for bourbon to 30 years or more for premium Scotch. The longer the whiskey ages, the more complex and mellow it becomes. However, aging also results in evaporation, known as the angel's share, which reduces the volume of whiskey in the barrel over time. Once the whiskey has reached its peak, it's filtered to remove impurities. Tennessee whiskey undergoes an additional step called the Lincoln County process, where it's filtered through charcoal before aging to create a smoother taste. Finally, the whiskey is ready for the bottle. It's diluted with water to reach the desired proof, typically 40% ABV. Each bottle is filled, sealed, labeled, and packed for shipment. Some distilleries hand bottle their whiskey, while others use automated systems. And that's it, from grain to glass. Every sip of whiskey carries the legacy of generations of craftsmanship and expertise. The next time you raise a glass, take a moment to appreciate the complex journey that brought that golden liquid into your hand. Now let's a closer look at the ingredients.
Rye is one of the most fascinating grains in agriculture. Its slender seeds, typically longer and narrower than wheat, come in shades of grayish-green when raw, turning golden brown after harvest and processing. The plant itself stands tall in fields, its green stalks swaying gracefully in the wind before transitioning to a golden hue when mature. While often overshadowed by wheat and corn, rye has carved out a niche for itself in American agriculture, particularly for its versatility and resilience. This grain thrives in cool climates and nutrient-poor soils, making it a reliable crop for farmers in regions with challenging conditions. It tolerates cold winters better than most other grains, making it a staple in areas where harsh weather is the norm. In the United States, rye is predominantly grown in the cooler parts of the Midwest, including states like Minnesota and Wisconsin, as well as in parts of the Northeast, such as New York and Pennsylvania. These areas provide the ideal mix of moderate summers, cool falls, and well-drained soils. Its ability to adapt to various uses and conditions makes it indispensable in the farming world. When it comes to harvesting rye, precision and timing are critical. The process varies depending on the intended use of the rye. Farmers must carefully decide whether to harvest the crop green for silage or wait until it's fully mature for food production or seed. This decision significantly impacts the equipment used, the techniques applied, and the ultimate quality of the harvested rye.
Did you know that over 2.5 million tons of instant coffee are produced globally every year? With its irresistible aroma and unmatched convenience, instant coffee has long become an essential part of the fast-paced lives of billions of people around the world. The journey of those tiny coffee packets begins in lush green plantations, where each coffee cherry is carefully harvested, either by hand or using modern machinery. From there, these black pearls go through a meticulous process that includes roasting, grinding, extraction, drying, and packaging to become fine, fragrant granules ready to energize coffee lovers everywhere. Today, let's join Agriculture Insight to explore the incredible journey of coffee beans, from the farm to the factory, and discover what makes this legendary beverage so irresistibly popular. Let's get started. instant coffee production process begins with one of the most crucial steps: roasting the coffee beans. This is when the beans truly transform, unlocking their rich aroma and signature flavor. Modern roasting machines operate at around 200 degrees Celsius, constantly rotating the beans to ensure even roasting without burning. During this stage, intense chemical reactions take place, creating the distinct coffee aroma and deep brown color. Once roasted, the beans are rapidly cooled and transferred to grinders, where they are ground into coarse powder, the primary raw material for the extraction phase. The ground coffee is placed into high-pressure extraction tanks, where hot water, at temperatures between 150 and 180 degrees Celsius, extracts the full spectrum of flavor, caffeine, and soluble compounds. Each hour, a factory can produce up to 18,000 liters of concentrated coffee extract. The liquid extract is then sent to a vacuum evaporation system, which reduces the water content and turns the coffee into a thick, concentrated syrup. This mixture is spread evenly over a 30-meter-long conveyor belt and moved into the freezing chamber. There, at temperatures between 40 to 50 degrees Celsius, the concentrate is completely frozen, a critical step that preserves the coffee's aroma and quality before drying. Even after freezing, the coffee still contains water in the form of ice. To convert it into dry instant coffee without damaging its structure or flavor, factories use a process called freeze drying under vacuum pressure. At around 60 degrees Celsius, the ice undergoes sublimation, transitioning directly from solid to vapor without melting. This method prevents aroma loss, clumping, and preserves the light, porous texture that makes the coffee easy to dissolve in hot water. After drying, the coffee granules are collected in large containers and transferred to automated packaging lines. Jars or sachets are filled within seconds, sealed airtight, labeled with product details, and undergo a final quality check before shipping. Every week, hundreds of tons of instant coffee leave these factories, headed to supermarkets, cafes, and kitchens across the globe. Let's leave the high-tech factory behind and return to where it all begins: sun-drenched, vibrant coffee farms. Trust me, you won't want to miss the stunning scenes of the coffee harvest. During the dry season, across vast coffee fields, nature and technology come together in harmony. The most advanced harvesting machines today glide through rows of coffee trees like diligent giants, working with precision and efficiency. Equipped with up to 1,500 vibrating rods, these machines create just the right amount of shaking to detach ripe coffee cherries without damaging the plant or unripe fruit. The fallen cherries are caught by soft, wide nets that minimize bruising or contamination. Then, they move along automatic conveyors where smart air blowers remove leaves, twigs, and debris, leaving only clean, high-quality cherries. The closed-loop system ends with automatic conveyors that transfer the cherries into large containers on trailers, moving alongside the harvesters, ready for the next stage. With a capacity of up to 12,000 pounds per hour, these machines replace the manual labor of over 100 workers, significantly cutting down time and costs. Even more remarkable, this technology allows coffee plants to be relieved earlier, giving them more time to recover before the next cycle, boosting long-term yield and quality. It's not just a solution to labor shortages, but a sustainable path forward for the global coffee industry. Alongside modern machinery, hand picking is still widely practiced in areas with steep terrain or when harvesting premium coffee varieties. Farmers carefully pick only ripe cherries directly from the branches, ensuring optimal quality. This method often involves multiple passes through the same trees to avoid collecting unripe cherries. The harvested cherries are gently placed into baskets and transported to the processing site. While time-consuming and labor-intensive, hand harvesting protects the plants and minimizes damage to the fruit. It's also the preferred method for producing high-end specialty coffee, where preserving natural flavor and exceptional quality is key. This artisanal approach reflects not only meticulous care, but also pride in producing some of the world's finest coffee, celebrated by growers and connoisseurs alike. After harvesting, ripe cherries are loaded into large trucks, each capable of carrying up to 20,000 pounds of coffee. These vehicles ensure fast and efficient transport to the initial processing stations, where quality begins. The first step is water-based sorting, simple but highly effective. The cherries are poured into large tanks where they separate based on density. Ripe, dense cherries sink to the bottom, while unripe, hollow, or damaged ones float and are discarded. In some regions, farmers still use traditional dry processing, spreading the harvested cherries under the sun for 7 to 14 days. This method saves energy and retains some of the natural flavors, but it requires favorable weather and careful handling throughout the drying period. After sorting, the cherries are sent to industrial pulping machines. Using rotating drums and gentle pressure, the machines strip away the outer skin and fruit flesh, leaving behind the coffee beans. The removed pulp is often repurposed as organic fertilizer for the next season. A great example of sustainable farming. However, the beans are still covered in a sticky mucilage layer that must be removed. This is done through natural fermentation, typically lasting 12 to 36 hours depending on the ambient temperature. Once the mucilage breaks down, the beans are thoroughly washed with high-pressure clean water, resulting in smooth, spotless coffee beans. Washed beans must be dried to reach a standard moisture content of 10 to 12%, which is essential for safe storage and mold prevention. Modern facilities often combine sun drying and mechanical drying, depending on the weather and production scale. Sun drying preserves the original flavor, but is time-consuming and weather-dependent. Meanwhile, mechanical dryers operating at 40 to 60 degrees Celsius can dry beans evenly and quickly within 24 to 48 hours, offering consistent and controlled results. Once fully dried, the beans are sent to hulling machines to remove the thin parchment layer left on the outside. This protective layer must be removed before roasting. Next comes grading, where the beans are sorted by size and weight using vibrating screens and gravity-based sensors. Larger, denser, and more uniform beans are selected. These are the top-tier candidates for producing high-quality, instant coffee.